So this video won't be too long, I would think. We're going to briefly summarize some key and common distinctions between metals and non-metals in terms of physical properties. And we'll start with metals. So metals undergo metallic bonding, which leads to similar properties of high melting and boiling points and conductivity as well, due to the free delocalized electrons within their structure, which can carry electrical charge. Metals are nearly always solids at room temperature. They're also quite malleable and quite dense, as we've mentioned in the last video. In terms of chemical properties, metals take up most of the periodic table, starting from the left-hand side. They usually have, well, actually always, in the case of the metals that we're looking at, always have less than half a full outer shell, and so tend to lose electrons in order to gain a full one. In losing electrons, they form positive ions, and the formation of these positive ions allows ionic lattices to exist and allows metallic bonding to take place within metals. For non-metals, like simple molecular substances and giant covalent structures, we see covalent bonding within both of them. But the properties of these two do differ quite a bit. Simple molecular structures tend to have quite low melting and boiling points and are liquids or gases at room temperature. They also don't conduct electricity as well. Giant covalent structures, on the other hand, are very hard substances with very high melting and boiling points. Some of them conduct electricity well, in the case of graphite, and others don't, such as diamond. So structures like graphite, which graphite does have a high melting and you can say very high actually. Graphite has a high melting and boiling points, and is conductive. It's quite similar to metals in that respect. But in terms of actual non-metal elements, non-metals occupy the right-hand side of the periodic table. They have outer shells which are more than half filled, and so those shells will usually be completed or usually be filled up by gaining more electrons, or sharing electrons in the case of covalent bonding, until there is a full outer shell. Gaining electrons to engage in ionic bonding usually, and sharing electrons to engage in covalent bonding.